Hi! Today we're going to talk about distributive property and combining like terms. So here we go. Our first examples that we'll focus on are up here, these two bubbles. Now, what's important to notice about these two bubbles is that they have different answers. So, right here, x minus 3x. They both have an x term. I call it an attachment. This first number is a 1, x, minus 3x. That's an imaginary 1 that we use. So, these 1 and this negative 3 have this thing attached to it, and I'm going to call it a backpack. So right now, I've got a 1 and a negative 3. So, using our integers, 1 positive and 3 negatives, you will end up with 2 x's. Now, a little more info about these backpacks. Backpacks, like x's, for example, this 1x and this negative 3x, they're going to hang out together because they have the same backpack. And did you know, people that don't wear the same backpack do not hang out with each other at all. Proven fact. So, let's keep that in mind as we are going through. Now, let's focus now on this second one, the second bubble over here to the right. So I've got x times negative 3x. It's like a mini distributive property problem. So what I'm going to do is I'm going to multiply the x times the x. X times x is x squared. I don't do anything with a negative 3. My answer is negative 3x squared. So I'm done with those two. All right, let's move on. You have to pardon me, give me a chance to erase for just a second. All right, here we go. So, write simplified expressions for the perimeter of the rectangle shown. Perimeter, let's talk about it. Perimeter means all the sides added up together. Well, right now, something I've noticed is that on number 1, only 2 of the sides are labeled. So this is one of those times where you need to think to yourself, what are the other 2 sides? So, let's figure that out. Well, if this side right here is 2x, then the side that's equivalent to it, the side that is mirroring it, is also 2x. Okay? Now the side that is x minus 1, it has a matching side over on the left, which means this is also x minus 1, right here. Okay, well, if I'm going to write the perimeter, that means I need to add up all the sides. So let's make sure that we write really small so we can fit it all in. Let's start with our orange sides. X minus 1 plus x minus 1 plus, now let's go to our green, 2x plus 2x. Again, feel free to pause anytime that you feel that you need to just catch up. All right, so now, let me make this more of a subtraction sign for you. Now I've got backpacks that are the same. And what I mean by that is, this x, this 2x, and this 2x all have the same backpack. They're going to hang out together. They're not going to hang out with anybody else. They're only going to stick together with themselves. So I've got 1, 2, 3, 4, 5, 6. 6x. Now let's switch colors. And let's do my constants, my numbers that are all by themselves. I got a 1, I got a negative 1. So this minus 1 here, this minus 1 here. Negative 1 and negative 1 together. Things that don't have any attachments, things that don't have x's, we'll just call those people that walk around school carrying folders. They don't have anything on their back. There's nothing attached to them. They're just carrying their folders around, you know. So, together, they're going to hang out. Together, they're going to make minus 2. The perimeter of number 1 is 6x minus 2. Please remember, 6x has a backpack. There is no way that it will ever hang out with this -2. They're different. They're not going to hang out in this math analogy. Let's go to number 2. On number 2 again, sides are missing. So it's our responsibility to fill in x plus 1. Go ahead and write that in. X minus 1. All right, so add up all the sides. Find the perimeter. Here we go. X minus 1 plus x minus 1 plus x plus 1 plus, I'm writing too big. I got to make sure to finish those plus signs. Plus x plus 1. All right, here we go. How many things with backpacks? How many x's do you see? Backpack, 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 x. Added them. They're all positive ones. 1x plus 1x plus 1x plus 1x. 4x. Now let's talk about these ones. I got -1 and -1 and +1 and +1. You can also choose to identify your matching terms, your like terms, by making zigzags or straight lines or curvy lines or wavy lines, whatever you like. Well, looking at all these green underlined ones, -1, -1, +1, +1, that comes out to 0. So the perimeter of number 2 is 4x only. All right, let's move on to 3 and 4. Here we go. All right, let me erase all the work from before. All right, here we go. Same thing as 1 and 2, guys. Fill in what you know is missing. Those are the things that are missing, okay? You're going to add up all the sides, which means you're going to write an expression, and you are going to add up all the sides. X minus 2 plus x minus 2 plus 2x plus 3 plus 2x plus 3. Okay, like terms. X's. Let's make these zigzaggies, so that we know that they all go together. X plus 2x plus 2x. 6x. Let's switch colors. And now I've got a -2, a -2, a +3, and a +3. Think about that one. -2, -2, +3, +3. The easiest way to do this, honestly, is to add the 3 plus the 3, 6, and then do 6, take away 2 is 4, take away another 2 is 2. And it's a +2. Perimeter, 6x plus 2. Let's do number 4. Fill in all the sides. This is a square. All 4 sides are the same on a square. So, since all 4 sides are the same, I'm basically going to try something different. Let's try and be a little bit advanced here. X squared plus x squared plus x squared plus x squared. Now, x squareds. These are also backpacks that I like to refer to. So in this analogy, these are the guys that have the rolly backpacks. They're super cool. So these guys with the rolly backpacks cruising through the campus, there's 1, 2, 3, 4 of them, and you know they're going to hang out together, man. They got nowhere else to go. They're just going to kick it with each other. Now let's look at all the numbers we have. I have a -3, a -3, a -3, a -3. I did wavy lines there. -3, -3, -3, -3. Altogether, combined, -12. All right, awesome. Doing good. Try let's really focus in on 5. Okay. So, like terms, again, will be a D and a 2D. So let's write out our expression. It's a triangle. There's 3 sides. The first side is 2D plus 1. The second side is D. And our hypotenuse, let's throw that in there, why not, is 4. Like terms, 2D and a D. And then 1 and 4. Which means that a 2D plus a 1D is a 3D. And let's do our greens now. 1 plus 4, 5. Perfect. All right. So, let's now erase all of our markings. All right, here we go. Try this one on your own. Press pause, work it out on your own. Add up all 3 sides. Find the perimeter. Make sure you press and pause. Did you get 9W minus 1? Yay! Good job. Awesome. All right, here we are on page 2 of our worksheet. So, let's go on to example number 7. Now, in example number 7, I've got to, let's move that down a bit, distribute. Now, this 1/3 has to get multiplied by both numbers inside. So, let's be careful and let's make sure that we draw our distributive property hoops. I call them hoops. All right, so draw the hoops. Here's what's happening. The 1/3 is going to get multiplied by the 3x. The 1/3 is then also going to get multiplied by the -6. So let's write it out, and I really think the best way to write it out looks something like this. Now, I'm going to turn 3x into a fraction because I want to show you how we can cross-cancel, cross-simplify. So, 1/3 times the 3x. First hoop, done. Second hoop, 1/3 times -6. Now, there is a subtraction sign right here. See that? So I'm going to draw the subtraction sign, and then I'm going to write my 1/3, and I'm going to put, again, make it a fraction, 6/1. So what happens here is that the 3's cross-simplify and both become 1's, which means that I have 1 times 1x. Then the 3 and the 6 simplify and become a 1 and a 2, which means I have minus 1 times 2. 1 times 1x is 1x minus 2. Keep in mind, the 1 has a backpack of an x. The 1 has a variable. The 2 does not have a variable. They are not like terms. You cannot combine them. All right, here we go. This one looks daunting, but just notice the 1/4 gets multiplied by all 3 numbers inside the parentheses. This is the distributive property. So here's what we're going to do. Pardon me. All right. 1/4 times 4x squared, make it a fraction over 1, because remember, if I'm going to cross simplify, let's make it look the easiest that it can for us. Plus 1/4 times 12x over 1. If they're both fractions, it's easiest to cross cancel to simplify. Now the last term, 1/4 times 8 over 1. All right, let's do our different color. Now, the 4's are both going to become 1's. This 4 goes into this 12. 4 goes into 4 once. 4 goes into 12 3 times. That becomes 3. The 4 becomes a 1. The 8, how many times does 4 go into 8? Goes in twice. So go ahead and make all those corrections on your paper. Here's what I now have. 1 times 1x squared plus 1 times 3x minus 1 times 2. Okay? Let's now do our multiplication. 1 times 1x squared first. 1x squared. Plus sign. Bring it right down. 1 times 3x. 3x. Perfect. Subtraction sign. Bring it. 1 times 2. 2. Here we've got some pretty cool characters here. Let's talk about them. The guy with the rolly backpack. The guy with just the plain old backpack, you know. And then this last one is a 2. Negative 2. They're all by themselves. You cannot combine them. You are done. Here we go on number 9. Take a look. There are like terms. There are like terms that we will put together. And then there is one number that is not a like term. It's basically hanging out by itself. A plus A. They both have backpacks. They both have variables. They have the same variable. Let's put those together. 4. He's just all by himself. Nobody's going to hang out with him. So he stays there just hanging out at the end. All right. I got a little bit of both here. I got some distributive property. Then I got this G at the end that I'm going to combine with the like terms. So here we go. Let's distribute first. 4 times 2, 8. 4 times negative G, negative 4G. And then this guy right here all by himself, just attach him to the end. Okay, what are the like terms? The G's. Put them together. There's a negative 4 and then there's a negative, remember, it's like an imaginary 1 in front. So I've got, and we always write our variables first. They are, let's say they have more power. They lead the way. They always will be written in front of a plain old number, which we call a constant. This positive 8 is a constant. It's just a number. So variables will always go in front. If we're going to do like hierarchy, it's like numbers that are like exponents, x squared, x cubed, then just x's, x to the first power, then numbers all by themselves. Let's move on. All right, for this next problem, it's going to be all Army colors. Because the men that serve in any branch, man, my hat's off to them. The best. So here we go. Let's do like terms. C's. Okay. So 3C, negative 12C. Then constants, numbers that are all by themselves. A negative 5 and a positive 8. So first let's combine the green like terms. A 3C minus 12C. Negative 9C. Now let's talk about the -5 and +8 plus 3. Perfect. All right, we're at it again, like terms. Ooh, these are the slick rolly backpack guys. Man, cruising through campus. Cool, cool, cool. 3x squared plus x squared. I've got 3 rolly backpacks and then one more rolly backpack. 4x squared. Then I've got plain old just normal backpacks on their back. A -4x and a +9x. They have the same variable, x. So let's just combine the numbers. A -4 plus 9. That's it. We are done. Great job. Talk to you soon.